Hello everybody and welcome to my channel. Kindly like, share and subscribe to receive all the update. Our topic today related to the spread of viruses, especially COVID-19, which is now currently the pandemic affecting the air conditioning system as well. Our subject is minimizing the spread of airborne viruses through air conditioning and ventilation systems. What are the steps required we can take to improve indoor air quality and keep our occupants safe? Recent research shows the virus that causes COVID-19 can survive in the air for much longer than other viruses, remaining infections for up to 16 hours. Do you believe that? 16 hours it stay in the air. We already know larger droplets, such as those from a cough or sneeze, are a key methods of virus transmission, but normal breathing and speaking still create tiny aerosol particles that remain in the air. Airborne guidance. The Center of Disease Control USA has also recently updated its guidance to include airborne transmission as a mode of transmission of this virus when in enclosed spaces with inadequate ventilation or air handling. Let's discuss some solutions. When we know how easily viruses are spread in public spaces, are there steps that hospitals, schools, offices, and other densely populated buildings should be taking to protect public health? What does the research show? Researchers from Tulane University investigated the durability of the tiny aerosol particles and how infectious they remain in the air. It was discovered that the SARS-CoV-2 particles that cause COVID-19 remain infectious for 16 hours with very little deterioration. This makes this strain an anomaly, as other types of coronaviruses deteriorate over this time. On the other hand, what are the different methods of air filtration and how to protect the occupants of our buildings through enhancing indoor air quality? What World Health Organization say about droplets transmission? Currently, World Health Organization considers droplets transmission of SARS-CoV-2 as a dominant mode of transmission, but does not consider airborne transmission to be one except in specific settings related to healthcare procedures. Inadequate ventilation or air handling can lead to very bad situations, which include the airborne transmission in the enclosed spaces that cause the spread of the virus. So CDC has recently updated its guidance to include airborne transmission as one of the modes of transmission of this virus in certain circumstances, such as in enclosed spaces through prolonged exposure to respiratory particles or resulting from inadequate ventilation air handling. That's why the ventilation and air handling is very important to minimize the effect of the coronavirus. So what are the procedures to minimize or reduce the spread of airborne viruses in indoor environment? The virus is most commonly spread through larger droplets, for which the most effective prevention is social distancing, safe hygiene practices, and PPE. We can control the airborne exposure through the through some control or changes in the operation of heating, ventilation, and air conditioning. Ventilation and filtration provided by heating, ventilation, and air conditioning systems can reduce the airborne concentration of SARS-CoV-2 and thus reduce risk of transmission through the air. However, disabling air conditioning systems is not generally a recommended measure to reduce virus transmission because unconditioned spaces can cause thermal stress to people that may be directly life-threatening and might also lower distance to infection. Increasing ventilation rate is one method that can deactivate infectious particles. Increasing the ventilation rate helps dilute pathogens and reduce exposure to contaminated air, but increase running cost. A ventilation standard such as ventilation standards such as ASHRAE 62, published by American Society of Heating, Refrigeration, and Air Conditioning Engineers, attempt to strike a balance between indoor air quality and energy consumption. The ASHRAE Standard 62.1 recommendations include increase fresh air supply and reduce air recirculation as much as possible when the building is operating under adverse conditions such as an airborne pandemic. Ventilation rates vary depending on the building, indoor environment, and occupants, but increased rates are usually associated with fewer adverse health effects. Ventilation rates can be increased naturally through windows or doors, or mechanically by fans or air handling unit. Methods to protect the occupants from the airborne transmissions and to maintain IAQ indoor air quality include EPM1 filters, HEPA high-efficiency particles air filters, UV disinfection, and bipolar ionization. Before we start talking about these methods, let's have a look on ASHRAE amid COVID-19 pandemic recommendations. Building owners are encouraged to improve the efficiency of the filters serving their HVAC systems within the guidance provided for most of the building types listed on the ASHRAE COVID-19 Preparedness Resources website. Mechanical filters are the most common types of filters found in HVAC systems. According to the ASHRAE position document on filtration and air cleaning, the term used to describe mechanical filter efficiency is MERV. MERV is an acronym for Minimum Efficiency Reporting Value. The MERV rating of a mechanical filter is determined by filter manufacturers in accordance with ASHRAE Standard 52.2. ASHRAE recommends that mechanical filter efficiency to be at least MERV 13 and preferable MERV 14 or better to help mitigate the transmission of infectious aerosol. Many existing HVAC systems were designed and installed to operate using MERV 6 or MERV 8 filters, while MERV 13 and greater filters are better at removing particles in the 0.3 micron to 1 micron diameter size, the size of many virus particles. The higher efficiency does not come without a penalty. Higher efficiency filters require greater air pressure to drive or force air through the filter. Care must be taken when increasing the filter efficiency in an HVAC system to verify that the capacity of the HVAC system is sufficient to accommodate the better filters without adversely affecting the system's ability to maintain the owner's required indoor temperature and humidity conditions and space pressure relationship. Now let's go to the first method, EPM1 filters. The filter group EPM1 is the group with the highest filter capacity. Different classes of particles matter can be defined according to the particle size range. The filters are classified into three fine particles according to the particle size range. Filters are classified into three fine particles filter groups: EPM10, EPM2.5, and EPM1, as well as one coarse particle filter group, ISO coarse. The most important ones are EPM10, EPM2.1, and EPM1. The filter group EPM1 is the group with the highest filter capacity. That's because EPM1 minimum 50% efficiency in particle 0.3 micron to 1 micron in size, e.g. particles that enter the body through the respiratory system, such as fine duct bacteria and smaller spores. Air filter element according to the ISO 16890 series are evaluated in the laboratory by their ability to remove aerosol particulate expressed as the efficiency value EPM1, EPM2.5, and EPM10. The air filter elements can then be classified according to the procedure defined in this part of ISO 16890. This photo shows the comparison between the old standard EN 779 and the new standard ISO 16890. We can see the minimum particle that can be controlled is 0.4 micron, while the use of the new standard can control minimum 0.3 micron. This slide shows the transmission between transitional period and the withdrawal of the old standard filters on the middle of 2018. The EPM filters also, while these air filters are not designed especially to prevent the spread of airborne viruses, their high filtration efficiency reduces the risk. They are considered as first line to reducing the risk of transmission of airborne diseases through HVAC systems. This is because viruses usually attach to airborne particulate matters and aerosol, which this filter removes from the air. Second type, HEPA, high efficiency particulate air filters. HEPA filters are designed to meet requirement of very fine filtration up to 0.3 micron at high efficiency of 99.99%. These filters are available with different coating like PTFE coating, PTFE limitation, and more for better dust releasing. Due to hydroponic and oleophobic treatment on media, it does not allow any moisture and oil contents to pass through it. These filters remove pathogens and are considered vital in critical environments within hospitals and healthcare facilities, since particles are trapped rather than deactivated. The filters must be treated and disposed as of as biohazardous waste using appropriate PPA. Third type, ultraviolet disinfection. Ultraviolet germicidal irradiation reduces transmission of airborne viruses and infections by using short-wave ultraviolet (UVC) light to deactivate pathogens and microorganisms including mold, bacteria, and viruses. Ultraviolet C works to sterilize the air by damaging the DNA and RNA of airborne pathogens, rendering them harmless. They can be used as stand-alone devices or installed into a HVAC system. They are commonly used alongside HEPA and air filtration as complementary systems for disinfecting high-risk areas of hospitals. Recent research showed ultraviolet C light sources effectively deactivate SARS-CoV-2 and a 5 mg/cm2 dose reduces the virus by 99% in 6 seconds. It is worth mentioning that direct exposure to ultraviolet UV rays can be detrimental to human health. Last method, bipolar ionization. Bipolar ionization was introduced in 1970s to control pathogens in food manufacturing and was effective during previous outbreak of SARS, norovirus, and more recently MERS virus. The technology takes in air molecule and turn them into bipolar charged atoms, positive and negative ions, before releasing them. These ions attach to and deactivate viruses, bacteria, mold, and allergens by producing a chemical reaction. They also increase their size and mass, which cause them to drop to the floor or to get caught by the filter. It works as an active process, continuously disinfecting air and significantly reducing microbes in a short time. Many hospitals and public buildings employ this method, and its main advantage is the ease of retrofitting it into existing HVAC system. Next step, we have to choose the best method to maintain the indoor air quality according to application or building type. So, number one, which systems are implemented in hospital? Currently, hospitals use central EPM1 filters, central and terminal HEPA filtration system, ultraviolet disinfection, and they apply higher ventilation rates compared to non-healthcare buildings. Some hospitals also utilize bipolar ionization. HEPA filtration is mainly focused on critical spaces where patients are at high risk, such as operating and isolating rooms, or where processes requiring clean environments are carried out, such as sterile IV preparation. In the Middle East, general patient care spaces commonly do not employ systems or technologies specially designed for removing or eliminating pathogens, but that is changing in newer facilities. Second, which systems are used in other buildings, i.e., commercial or residential? In the vast majority of non-medical buildings, Nothing is used that is capable of removing or eliminating pathogens. Some buildings employ APM1 filters and a smaller portion employ bipolar ionization. Most rely mainly on ventilation to dilute airborne pathogens, although this cannot happen fast enough to prevent spread through HVAC systems. In an airborne pandemic situation such as SARS-CoV-2, and especially not in high-density occupancies. Now, what are the regulations governing air filtration in densely populated spaces during an airborne pandemic, such as COVID-19? Currently, there are there aren't any. Yes, there aren't any. However, guidance and advice has been issued by ASHRI, SIPSI, and REVA. These organizations provide up-to-date information on how to operate and use building services to minimize virus spread through HVAC and plumbing systems. Here is ASHRI website recommendation. ASHRI offers COVID-19 building readiness reopening guidance. You can go to the link, it is in the end of this video. You can see what ASHRI recommends. Also, SIPSI as well, recommendations. And last, REVA recommendation. REVA COVID-19 guidance directory. REVA actually has COVID-19 guidance, COVID-19 course, COVID-19 webinars, COVID-19 frequently asked questions. However, it is very important that the governmental and national public health institutions should be consulted for each country to confirm regulations. Will there be regulations, or will more buildings implement these systems as a result of the pandemic? There should be changes made to the current codes, standards, and regulations as a result of the pandemic, especially since scientists believe pandemic will become more common. Building assessment. Following the guidance from ASHRI, SIPSI, and REVA, building readiness plans, assessments, and systems evaluation should be incorporated into future editions of codes and standards. There are some solutions. Furthermore, changes should be introduced to ventilation design, such as including an inbuilt pandemic operation mode in the controls where Number 1, more outdoor air is introduced. Number 2, higher efficiency filters temporarily replaced standard filters. Number 3, fan speeds are ramped up to overcome the resistance from these filters. Best approach. Alternatively, a general increase in the fresh air requirements and filtration efficiency under normal operation may be considered. Also, limitations on the sizes of zones sharing HVAC equipment might be enforced in new buildings to limit the spread of pathogens. However, it is not sustainable for HEPA filters or UV disinfection to be broadly implemented due to the high capital and operational costs and consequent environmental impact. What is the best advice for the current and new buildings? Governmental and national public health institutions should be consulted in each country to confirm regulations for business and public spaces. Follow the advice issued by ASHRI, SIPSI, and RIVA, created a building readiness plan, and conduct a system evaluation to maintain high indoor air quality and minimize occupants' exposure to airborne virus particles. The potential benefit to public health during this pandemic will outweigh the temporary reduction in energy efficiency that comes as a result of these measures. Thank you for listening to this video, watching this video. Please like, share, and subscribe in my channel. Here are the important links which I talked to you before. Thank you.